Good morning, everyone. Today we are going to start a new topic, that is your angular momenta in an atom. So, what is an angular momenta? Angular momenta is a fundamental quantity which is used. This is a fundamental quantity which helps us to understand the structure of the atom, the splitting, the Zeeman effect, this type of effect, how the spectral lines split in the presence of electric field, magnetic field. That all to understand that all things. First of all, we have to know the knowledge. We have to gain the knowledge of the angular momenta in an atom. So, what is angular momenta? Let us first of all define it as that angular momenta in an atom is what? In an atom is a quantized rotational motion associated with an electron due to its orbital motion around the nucleus and its intrinsic spin. So what is angular momentum? Angular momentum क्या होता है? एक quantized rotational motion होता है associated with electron. What does the term quantized mean? What quantized? Quantized mean it will have a certain allowed values only. It will not have a continuous value. It will have a certain values allowed. That is, it will like if we are having the values for the orbits. Therefore, we can say that is the values in the angular momentum in atom are what quantized. What quantized rotational motion. Here, what the motion is, what the motion of the electron is, what rotational. It is orbiting around the nucleus. So, moving towards the definition, we have the angular momentum is an angular momentum in an atom is a quantized rotational motion on motion associated विद एन इलेक्ट्रॉन जो मोशन है ऑर्बिटल मोशन जो ले रहे हैं हम लोग यहाँ पर वो क्या है उसका एक मोमेंटम होता है वही आपको क्या दे रहा है ऑर्बिटल मोशन के कारण क्या दे रहा है कोई मोमेंटम दे रहा है किसके अराउंड न्यूक्लियस के अराउंड क्या कर रहा है ऑर्बिट कर रहे हैं और एक होता है इंट्रिंसिक स्पिन जस्ट लाइक अर्थ revolves around the sun we are having the orbit electron is orbiting around the nucleus and earth rotates around its axis. So here we are having the electron. It also has its intrinsic spin as the Earth rotates itself. Earth rotates on its axis. We have electron spinning. What? Electron spinning around its axis. Okay. So this is the main concept that is angular momentum in atoms. The angular momentum are studied in three parts. There are three types of angular momentum. First is your orbital angular momentum, represented by capital L. Spin angular momentum represented by S, and the third one is the total angular momentum represented by J. The combination of both this orbital L and spin angular momentum gives you the total angular momentum. Let us start the orbital angular momentum. Now, what is orbital angular momentum? Orbital angular momentum. Moving to the definition from the diagram, we have this is what orbit. Electron is in motion in the orbit around the nucleus. What is this? This is your nucleus. Okay. So, what is orbital angular momentum? The momentum when created when due to the orbital motion of the electron. What is the orbital motion? When the electron revolves around the nucleus, that is called as orbital motion. And because of this the momentum created that is called as your orbital angular momentum. The orbital angular momentum is represented by capital L. Okay. So the magnitude of the orbital angular momentum is given by L equals to root over L plus 1 h cut, where h cut equals to h upon 2 pi. Here h is what? Planck's constant. Small l is your orbital angular momentum, orbital quantum number. We have already discussed about this topic, orbital quantum number. And as we know that the orbital angular momentum or angular momentum in atoms is what? Quantized. ये क्या होता है? Quantized होता है. तो allowed values of L जो है discrete values of L allowed होते हैं. तो यहाँ L का value कहाँ से होता है? L equals to 0, 1, 2, 3 till n minus 1. Here n is what? Your principal quantum number. Already we know that principal quantum number is your also having the values from the starting 1 to n. So here we are having the different. Here we are having a table, a tabular format. Here we are having L, orbital, and name. Okay, name of the orbit. So if we are having the L equals to 0, if we are having the value of L equals to 0, then the electron is present in the S orbital. And the S, the name of the S is your sharp. that stands for sharp. If L equals to 1, we have p orbital, that is a principal orbital, and for L equals to 2, we have d orbital, that is your diffuse, and we have the third is your L equals to 3, giving you f orbital, that is your fundamental orbital. This was the concept of the orbital angular momentum. We are going to study that as spin angular momentum. This is the second type of the angular momentum, that is a spin angular momentum. What in 1925 में क्या होता है, उलनबेक और गॉड-स्मिथ क्या होता है, जो वेक्टर एटॉमिक मॉडल है, ठीक है, उसमें ये कहते हैं इन द फीचर्स ऑफ द वेक्टर एटॉमिक मॉडल ऑफ द दैट इज स्पिनिंग इलेक्ट्रॉन, ठीक है, तो उसमें ये बताते हैं कि इलेक्ट्रॉन जो है वो ऑर्बिट तो कर रहे हैं अराउंड द न्यूक्लियस, बट इट इज आल्सो व्हाट स्पिनिंग अराउंड on its own axis. What that Uhlenbeck and Gauss-Smith proposed in 1925 that electron spin about its own axis. वो क्या अपने own axis में क्या करता है, spin करता है, as we are having that electron is spinning around its own axis. As we can take example that we know that about our solar system, that the sun is what stationary. Here we are having the nucleus stationary. Here we are having the sun stationary, and the planets revolve around the sun. As we know that Earth also rotates around its axis, so similarly we have also the theory by Uhlenbeck and Gauss-Smith that the electron spin around its on its own axis. ठीक है, ये on its own axis. This is spin even exists when even when electron is not orbiting spin axis. अगर इलेक्ट्रॉन जो है ऑर्बिट नहीं कर रहे हैं न्यूक्लियस का अराउंड, तो भी स्पिन एग्जिस्ट करेगा. क्यों? क्योंकि स्पिन क्या है, आपका इंडिपेंडेंट क्वांटिटी होता है. ये क्या है, ऑर्बिटल मोशन से उसको लेना देना नहीं है. यहाँ क्या है, स्पिन और स्पिन जो है, इलेक्ट्रॉन का स्पिन जो है वो क्या है, इंडिपेंडेंट क्वांटिटी होता है. ठीक है, मतलब इट इज दैट द स्पिन इज इंट्रिंसिक स्पिन. ठीक है, सो नाउ magnitude of this spin angular momentum, we are having the magnitude of this spin angular momentum given by the equation that is your s equals to root over small s into s plus 1 into h. ठीक है, here small s is your spin quantum number. Already we know that h equals to h upon 2 pi, where h is what, Planck's constant. Now we are going to study about the total angular. What is total quantum number? What total quantum number? So total quantum number is what, vector sum of orbital angular momentum and spin angular momentum. ठीक है, total angular momentum is what, vector sum of orbital angular momentum and spin angular momentum together, adding the orbital motion and the electron's axis motion on its own axis. So the vector sum of this, as we know that angular momentum has its direction and magnitude, so it is a vector quantity. So we are having a vectorially sum, that is J vector gives you total angular momentum, that is equals to L vector plus S vector, where L and S are orbital and angular, ergo orbital and spin angular momentum. Now the magnitude of the total angular momentum is given by J equals to root over J, small j minus small j into J plus 1, that is into H cut. Here small j is what, total quantum number, h cut is your h upon 2 pi, h is your length. Now this z component of what, all angular momentums. ठीक है, so z component of the orbital angular momentum is given by Lz equals to ml h cut, where ml have the values that is a minus L2 plus L. ठीक है, spin angular momentum, in this we are having Sz equals to ms h cut. ठीक है, where ms equals to having magnetic spin having plus half and minus half. ठीक है, and the total angular momentum will be similarly Jz equals to mj. Thank you.